Hey Kennedy, this is Miss Tracy. So let me get some graph paper right quick, and then we'll look at this problem. I probably should have done that first. All right, so we're trying to find the rectangular coordinates for these polar coordinates. Now, lesson 54 talks about rectangular coordinates, and 59C talks about converting from polar to rectangular or vice versa. Now we just talked about, and I'm not sure what lesson 70 something, we talked about negative, what this negative means in front of a degree. And I'll show you again what that is to remind you. It's in the video. So a positive degree is when we start measuring from here and we go around just like normal, right? We go to the positive side of the y-axis. We go up. Actually, I'm going to leave that here. So that would be going towards the positive degree. But when you have a negative degree, it's because you started going toward the negative side first. That'd be a negative degree. You measure from here clockwise instead of from here counterclockwise. All right, so instead of going to quadrant 1, 2, 3, 4, you go quadrant 4, 3, 2, 1. All right, it's just in the opposite direction. Does that make sense? All right, so because, let me get all of this undone here. Because this is a negative 250, you're going to start measuring from here, and you would say, all right, 0 to here would be a negative 90. From here to here would be a negative 180. And then from here to here would be a negative 270. So we know that this vector lives in this quadrant because it's between 180 and 270. And we can also see that because it's 250, it's going to be 20 degrees less than 270. So if we come right here, let's get our line, and that's not a line, that's a, there we go. So it's going to be 20 degrees. So I'm just going to guesstimate that that's about 20 degrees. Doesn't have to be perfect. So if this is 20 degrees, right? 20 degrees would bring negative 250 up to 270, right? So we can see that math. 270 minus 20 is 250, right? 270 minus 250 is 20 degrees. All right, we got that right here. But that doesn't help us find this. This is what we're looking for. This degree of measure here is what we're looking for. We do know, however, that this is a right angle, and that 90 degrees minus 20 degrees is equal to 70. So this angle has to be 70 degrees right there. So we found our degree here, right? Now this is a positive number, so it stays on this side. If it were a negative number, we would have to flip the vector, right? In this instance, opposite literally means flip. It means the opposite. The negative literally means opposite. So if it's a negative degree, you measure in the opposite direction, and if you have a negative number here, which is the length of your hypotenuse, you would go in the opposite direction. But because this number is positive, it's going to stay right here. I'm going to get rid of this 20 just because we don't need it anymore. We just used it to find our answer. Now what we need is the length of the hypotenuse, which is 3. Okay. And I'm going to do my little relative triangle, right triangle, and that's going to give me my my location and my shape of my right triangle. So that's going to give me how I need to find my rectangular coordinates. So because of where this is located and because of where the right triangle is, this is a negative r and this is a positive u. Because it's up, it's above the x-axis, so it's positive. It's on the positive side of the y-axis, right? This is your positive y. This is your negative y. This is your positive x. This is your negative x, right? They're split from the origin. This is the negative side of the x-axis. So this is on the negative side of the x-axis, so it's a negative r. We've got to find this point right here. That length is your r value, and this height is your u value. So how do we do that? How do we find that? We use our degree of measure, and we use SOHCAHTOA. Right? Sine, cosine, tangent. So because we have the length of the hypotenuse, we only need the formulas that have a hypotenuse in it. We don't really need TOA. We don't need that. TOA is what we use when we don't know the degree of angle. So we can skip that one. So now it's all about which one is relative. So cosine of this angle, the cosine deals with the adjacent and the hypotenuse. Well, negative r is the adjacent side of this 70-degree angle. It's the one that makes up the 70-degree angle with the hypotenuse. So that's what we're going to use to find the value or the length of r here. And negative r doesn't mean anything. It's not a negative number per se. It just tells us where it is in the coordinate system. So we are going to take the hypotenuse, which is 3, times the cosine of 70 degrees. And then it's going to tell us the value of that negative r term. Likewise, we're going to take the hypotenuse times the sine of that 70 degrees, and that's going to give us our u term, because sine is using the opposite side, and the side opposite the 70-degree angle is the u side, right? So sine goes with u, and cosine goes with r. So now we just do the math, and we pull up our calculator for that. So I'm going to say 70 cosine times 3 equals. And we're going to go to 2 decimal places. This would round that 2 up to 3. So that's going to be 1.03 is equal to negative r. All right. Now, we're going to do the same thing for u. (70) sine times 3. And we get 2.819. We round that to 2 places. It's 2.82. So 2.82 is equal to positive u. We rewrite that as rectangular coordinates, and that's going to be, we take the negative. We never want a variable negative, so we transfer that by multiplying both sides by -1. Negative 1.03 is equal, hello, it's no longer an equal sign. Negative 1.03 r plus, because this is a positive, 2.82 u. That's it. That's all you're doing. This negative sign is only relative to the side that you start measuring from. That's all you care about. It's to help you locate where it lives on the coordinate system. All right. And like I said before, if this had been a -3 here, then you would have taken this and flipped it over and done 20 degrees here and 70 degrees here, and it would have been relative to this x-axis. But because this was not negative, we did not flip it over to the other side. We did not get its opposite, because in this instance, literally the negative just means the opposite. You do the opposite, or you go the opposite direction. Okay? And that's it. That's all we're doing. That is how you do it. Lesson 54 and lesson 59C tells you how to do the rectangular and the polar coordinates. And then I'll have to look up what lesson number it was, but in a different lesson, one that we did recently, somewhere in the 70s, it tells us that the negative just means you're changing which direction you go when you measure out to find that angle. And that's where we are now. Okay? All right, I hope that helps clear everything up. If you have any more questions, please let me know.